Now we're going to look at the economizing problem for the individual. So this looks a little bit different than the economizing problem for society. For individuals, they have a limited income and unlimited wants. And this is true for everyone, even for the richest people in society like Bill Gates. He still has a set amount of income and then has to decide how he's going to use his income. Even though he can buy anything that he wants with his income, he still gives away a lot of money to charity. He would love to have more income to be able to give away more money, and he has to decide which charities he's going to support. So all of us, including Bill Gates, have a limited income and unlimited wants. So to dig into the economizing problem a little bit deeper, we're going to be looking at the budget line. Now, the budget line is a graph, and we're about to go through it on the next slide. The graph is going to be two goods that can be purchased. So each of the goods will go on the two axes, and then the line will show you the certain amount of income that a person has to spend. And from that, you'll be able to see attainable or unattainable combinations. That would be amounts of the good that the person is able to purchase or unable to purchase. And we're also going to be able to see how opportunity cost works. So you're going to see the trade-off that happens between the two goods. If I want to buy more of one good, I have to give up an amount of the other good so that I can have my money free to purchase the first good. And so we're actually going to solve for what the trade-off is between the two goods, which is also the opportunity cost. And we're going to do that through calculating slope. We're going to work through an example here. So we're going to be graphing the budget line over here. What you'll be getting is an individual's income, and they've given that to us right here. So this person has $120 to spend, and they'll be spending that money on two different goods. One is movies and one is books, and that's what's going to go on the axis. So books I've put here on the vertical axis and movies on the horizontal axis. You're also going to get the price of each of the two goods. So the price of movies is $20 and the price of books is $10. And normally you don't get all this information down here. We're just going to be solving for what we really need to plot the graph. So the first thing you're going to do to draw your budget line is you're going to look for the two end points. And what I mean by end points is the two that are actually going to go on the axis. The way you want to think about the end points is if the person spent all of their money on books, how many books could they purchase? So they have $120. Books cost $10 a piece. So if you take the total income, $120, and you divide by the price of the books, $10, then you'll find that they're able to purchase 12 books with their money. And that will be our first endpoint that's going to go right here on the graph. So here's where our first point is going to go. And then we're going to find our other endpoint, which will go down here. And that will be if the person spends all of their income, how many movies can they purchase? So we do the same thing. We just take the total income, $120, divide by the price of the movies, 20, and we'll get 6. So if they purchase 6 movies, then they'll spend all $120. And you can plot that point right here. The next step, all you have to do is draw a straight line between the two. And that is your budget line. So the budget line actually shows you if the person spends all of their money, how much of the two goods could they purchase. So if we're looking at any point along the line, like for instance, this point right here. At this point, the person is purchasing 8 movies and 2 books, and that's going to cost them exactly $120. So if we're on the line, they've spent their entire budget. That's why we call it the budget line. If they're below the line, so for instance, if we're at this point where they're purchasing 4 books and 2 movies, right here, this point is what we call attainable. It's possible they have enough money to buy 4 books and 2 movies, but they actually have some money left over if we're underneath the line. So this is called an attainable point. We also have unattainable points, which are outside the line over here. So for instance, this point right here, they would be purchasing 8 books and 4 movies, but this is over their budget. They don't have enough income to purchase 8 books and 4 movies. So we call that point unattainable. It's actually just not possible. The next thing we're going to do with the budget line is to solve for the opportunity cost. And to do that, we're going to solve for the slope. We're not going to get too much into the math here. This is going to be pretty easy. We're just going to do slope as rise over run, and we're going to compare the 2 endpoints that we just found. Anytime we solve for the slope, it actually gives us the opportunity cost of 1 of whatever is on the horizontal axis. So as we're doing this, if we're looking at our rise, the rise is how far in the graph we have to go up or down to get to the other point. So if we start at this point right here, we're trying to travel to our other endpoint. Our rise will be the distance from here to here, which happens to be our endpoint is just 12 books. So our rise is 12 books. And we'll divide by our run, and the run is the distance horizontally that we're moving from right to left. So if we're moving from this point to this point, then we've moved to the right by a distance of 6 movies. If we reduce this, we will get 2. And that actually tells us 2 books per movie. And that's our opportunity cost. So what we've actually found here is the opportunity cost of 1 movie is 2 books. And we can do this the same way every time with finding the slope and relying on our 2 endpoints. When you're working on the opportunity cost on the budget line, always think of the trade-off of one good for the other. If this person wants to buy 1 more movie, they have to decide not to buy 2 books. So that's the trade-off between the 2 goods. The main takeaway from the budget line, make sure you know that the budget line is one individual that has a limited income and is choosing how to spend their income, and that they get stuck at their budget line. So anything below the budget line is attainable, they can afford it. Anything outside the budget line is unattainable. And then you'll also need to know how to find that trade-off or opportunity cost between the 2 goods. Here's one for you to try. So you have your individual, Hurley, with an income of $1,200. He could purchase 2 goods, either fish or mangoes. Fish are $4 and mangoes are $1. So the first thing you're going to do is find your 2 endpoints. If he spends all his income on fish, how many fish can he buy? If he spends all his income on mangoes, how many mangoes can he buy? And then here's a more challenging one for you if you want to try it. If Hurley buys 100 fish, figure out how much he spent on those 100 fish, how much money he has left over, and then how many mangoes that he can buy with his remaining income. Then go ahead and sketch out the budget line. So you can plot points A from here, point B from here, and if you connect the 2 dots, you should get a straight line, and that will be your budget line. You can also plot point C, and you'll see it should end up right on that budget line. So graph the budget line for Hurley. When you're done with the graph, solve for the opportunity cost of 1 fish. And then for F, Hurley's income falls to $800. see what will happen on the graph if Hurley has a reduction in his income. So pause the video now if you haven't done that yet, and then play when you're ready for me to go over the question. So step 1, if Hurley spends all his income on fish, how many fish will he buy? What we can do here is just take his total income, $1,200, and then divide by the price of fish, which is $4. And you'll see that Hurley can purchase 300 fish. Keep in mind, if he's buying 300 fish, then he doesn't have any money left over to buy any mangoes. Okay, now we're going to do the next part. If he spends all his income on mangoes, how many mangoes can he buy? Well, it's the same process. So income, $1,200, divided by the price of mangoes is $1. That's easy math. 1,200 mangoes. Now for C. This one is a little bit more complicated. What you want to do here first is decide if he buys 100 fish, how much will that cost him? So 100 fish at $4 a piece means he's spending $400 on fish. So how much does he have left to spend? Well, total he had $1,200. He's spent $400, so he has $800 left to spend. If he spends $800 on mangoes, and mangoes are $1 a piece, that means that he can purchase 800 mangoes. So in part C, now he's buying 100 fish and 800 mangoes. Then what we're going to do is we're going to plot points A through C. Our graph, we're just going to take our end point from A. He purchased 300 fish, and I put fish on the bottom axis here. So we'll have an end point right here at 300. And then B, he purchased 1,200 mangoes, and I just put 1,200 on my graph right here. And so our end point for mangoes will go right here if he spends all his money on mangoes, and you just connect the two. Now, if we look at C, Hurley bought 100 fish, and he had 800 mangoes. If we plot that point, 100 fish is somewhere around here, 800 mangoes is somewhere around here. So if we plotted the point, we would actually end up right around here. So we actually have point C that's right on the line. And I know it's on the line because he spent all of his $1,200. Next step, we're going to solve for the opportunity cost of one fish. So remember, when we're solving for opportunity cost, we're going to find the slope, or the rise over run. In this case, our rise is the vertical portion here, so 1,200 mangoes, divide by the run, which is this part right here, which is 300 fish. So what we get is, for every one fish, Hurley would have to give up 4 mangoes. That's how we solve for opportunity cost. Now, for F, show what happens to Hurley's budget line if his income falls to $800. The easiest way to do this is to redo just part A and part B and use his new income of $800. So for A, if Hurley spends all of his $800 on fish, how many fish does he buy? You just take the $800, divide by the price of the fish, which was $4, And that means that he's able to purchase 200 fish now. So instead of being able to purchase 300 fish, now he can only purchase 200 fish. So that's probably somewhere around here. We'll call that my new endpoint. And then you want to do the same thing for B. If he spends all of his new income, $800, on mangoes, how many mangoes can he buy? Since mangoes are $1 a piece, if he spends all $800, he'll be able to purchase 800 mangoes. So that would be somewhere around here. That's my new endpoint. And then all we have to do is connect the dots. So that's what our new budget line looks like if his income falls. So if an individual has a decrease in their income, the entire budget line would shift inward. If they have an increase in income, then the whole budget line would shift outward. And what actually happens here is you can see all of this area in here. This is points where Hurley before was able to purchase that amount. Those were attainable points. Now that he has a decrease in income, all of these points here now are unattainable because he can't afford them anymore.